Wand was alleviating his boredom by working on a weird mathematical problem. He started to wonder if the math could be interpreted physically. Eventually, he realized that it seemed to describe a new type of particle. Austrian physicists say a third class of particles, called ParaParticles, can indeed exist. They say these particles could produce strange new materials. No two fermions can be in the same place at the same time. Bosons have no such restriction. This is what makes it possible to build lasers which emit many identical light particles. When two bosons swap places, their quantum state stays the same. That's in part due to a fundamental feature of quantum theory. The minus sign disappears when quantum states are squared. In theory, quantum particles can also have hidden internal states, mathematical structures not seen in direct measurements. A third, more general category of particle, known as a paraparticle, could arise from this internal state changing in a myriad of ways. In the early 1980s, physicist Frank Wilczek came up with a theory of particles called anyons that can't be described as either bosons or fermions. To get around the DHR theorems, paraparticles in 3 dimensions that could form a solid still seemed impossible. That is, until now. In their model, in addition to the usual properties of a particle like charge and spin, groups of paraparticles share extra hidden properties. The researchers considered the fact that quantum systems can exist in multiple possible states at once. They imagine switching between the perspectives of observers who exist in these superposed states, each of whom describes their branch of reality slightly differently. The researchers found that paraparticles are impossible. For a particle to be truly indistinguishable by measurement, as physicists expect elementary particles to be, it must be either a boson or fermion. Paraparticles are able to pack just a few particles into the same state before getting crowded and forcing others into new states. While swapping 2 paraparticles has no effect on one person's measurements, 2 observers, by sharing if paraparticles exist, they'll most likely be emergent particles that show up as energetic vibrations in certain quantum materials. Bryce Gadway, an experimental physicist at Pennsylvania State University, is optimistic that paraparticles will be realized, and for now, the third kingdom of particles remains wholly theoretical. Paraparticles might become important, says Nobel Prize-winning physicist. You just prepare them and watch them evolve.